Alrighty, everyone. We're now moving on. I think it's part 6. I think it's going to be 8 total by the time I'm said and done with this series. It might be a little bit more, but I'm going to try and keep it at 8. I hope at this point you guys have gotten a lot of the murk and muddiness cleared up. I hope a lot of things are starting to make more sense to you. I'm trying to do it in such a way that I'm giving you the absolute basic information that you need, but it's enough information that if you want to go and research it, I've now armed you where you don't have to just sit there and figure out and start from scratch, and you can put the pieces of the puzzle together. So in this video, we're going to talk about how to interpret your soil test results. Now, soil test results, believe it or not, can be very different. You could take one test with one company, get one result, and take a test with another company and get a totally different result. Now, part of it could be where you took the samples because you didn't take them in the exact same spot, or maybe not the exact same depth. But a lot of the times it centers around right here. There are two main methods. There are a few others, but I'm not going to get into all of them. You can research that. But the two main methods that soil testing labs use is the Mehlich 1 or Mehlich 2 or 3. And I hope I'm pronouncing that word properly. That's how I see it, but you see how it's spelled. What this has to do with is the extraction solution and the method in which they extract the minerals out of the soil, put it into solution, and then put it into the testing unit to test it. If you remember in a previous video, we were talking about the colloid, the soil particle, and the colloid solution, which is basically the water with all of the nutrients and miniature particles of colloids of the soil in suspension within that soil so that the plant can intercept it with the roots. Typically, although it's not a guaranteed thing, a Mehlich 1 test is going to return in your macronutrients pounds per acre. Your micronutrients typically will be parts per million or ppm. Your Mehlich 3, on the other hand, typically are parts per million, as you can see right here. Now, you can convert parts per million by taking it and multiplying, or if you're converting pounds to part per millions, it's pounds times 2. If you're trying to convert ppm back to pounds, then it's ppm divided by 2. So what I have here is a soil test, and this one happens to be the way that Virginia Tech does it. If you look, our macronutrients, potassium, calcium, phosphorus, potassium, calcium, magnesium are represented in pounds per acre. But when we get into the micronutrients, they are represented in parts per million. You know, zinc, manganese, copper, iron, boron. If you remember what I told you in the balanced soil balanced soil method, you notice that I told you that phosphorus, at least in Virginia, now it can change state to state, and it can even change with different test methods, but phosphorus is typically 100 pounds per acre here in Virginia. I have seen some deviations in other states. But the rest of these guys are directly related to this CEC right here. There's that term again, cation exchange capacity. Now you're understanding why I did everything and built up to this point. Now, if you look at something like the Soil Savvy test You don't see the buffer index. You don't typically see the CEC. You don't see the base saturation. And then look at this. It actually is giving us the percentages of saturation for calcium, magnesium, and potassium. That right there isn't so much important, although it's very nice to have, as it is to have these two numbers right here, the buffer index and the CEC. The buffer index is, they basically calculate that based on how much of the extraction solution it took to produce the result, and that is the ability for the soil to buffer nutrients. In other words, think of it when you watch a YouTube video. You watch a YouTube video and there's this gray bar going ahead, and as long as that's ahead of the video, it keeps playing. But if it ever catches up with it, it stops, and then it buffers, and it goes up, and then it plays again. That's what this guy right here does. He basically is saying, okay, I have this CEC, but I also have a buffer in which I can actually cache or store stuff to make it available. The better this number, the better the soil is going to be, just like the better the CEC. Now, if you remember in the balanced soil video, I showed you that for one CEC, there were certain values for potassium, calcium, magnesium. There's also the same thing for, well, excuse me, I'm getting ahead of myself here. That's for your macronutrients. When you get into your micronutrients, these guys have a constant. I can't remember all of them off the top of my head, but I can tell you that iron, Fe, is typically 100 to 150 ppm. That's a constant. All of this you can go find online, and I would recommend you find it based on the test you are using and match it to that, because there is some deviation. So like Virginia Tech uses the Mehlich 1 extraction method. If you see here, it says high minus, very high, sufficient, 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 sufficient. Well, a high minus means that it's borderline low. A high plus means that it's optimal. A medium or lower, you've really got something else going on. You have to know what these numbers are supposed to be based on the extraction method of the soil test. pH here is self-explanatory. The acidity and everything, all of this is pretty much self-explanatory as to what's going on. This test right here, pH wise, I am dead mark on my sweet spot. I like 6.5 to 6.8. This is actually a customer's test here. That's why this paper's here, to cover the customer's name. And these right here can actually change throughout the season. Now notice, there's something I want you to notice. Notice there's no nitrogen in this test. Most of your tests, excuse me, I didn't mean to have the hand in the way there. Most of the tests do not test nitrogen. And the reason being, you've heard us talk about it. Leaching in the soil, volatility, it evaporates into the air. By the time you get this test done, the nitrogen levels can be completely different from what it was when you took the test. So let's look at this one for an example. And this particular one, the calcium is high. So is the magnesium, based off of what the CEC, and if you really want to get technical, there's another calculation for buffer index, but for what we're doing here, we really don't need to get that nitty-gritty as DIY people. Now, me doing it professionally, there is another calculation that needs to be done to get it spot on. But basically the way I do these tests is I've got a spreadsheet and it's got that CEC matrix that you saw. I key in the CEC and I key in all of these values, and then it does a multiplication off of a base of 1. And then it comes back and tells me exactly how many of these I need. And again, go back to the balanced soil video that I did. These guys right here, they're constant. So I key them in and I see what I have based on the key in and on the actual what it should be. I also use Waypoint Analytical. Now when I use Waypoint Analytical, it looks totally different than this. It's all bars and graphs and it's real colorful, and that one is a Malich 3 if I'm not mistaken. And it's all of it's given in parts per million. So basically I have to take the ppm, multiply it by 2 to get what my balanced soil matrix is. So now that you kind of get a brief understanding of how a soil test is interpreted, and you base it off of what I showed you off of that matrix, of all the stuff in balanced soil. Your key labs, at least here in Virginia, that we can use is Virginia Tech. They use Malich 1. Waypoint Analytical, I am pretty sure they use Malich 3. NC State, I'm pretty sure they use 1. Spectrum Analytical, I could not find out for the video tonight. I'm going to find out and try and cite it for you in the description in this video. Logan Labs, if I remember correctly, was 3, and I think Soil Savvy is also 3. As you see, I have my constant here in Virginia, per Virginia Tech. Phosphorus is supposed to be 100 pounds per acre. What I would encourage every single one of you to do is you need to find a replicable source. Your Ag Extension Office or Conservation Extension Office, depending on the state you're in, is an invaluable source to find that based on the soil types in your area. There's also some things you can go online and they kind of break the major geographical areas in the state down by soil types, and you can get all that information there as well. So, to this point, what we have done, we have discussed soil colloid, what it is. We have discussed cation exchange capacity, cations and anions, and how they interact in the soil and what does what. We have talked about balanced soil, what it takes to balance it. We have also discussed the different grades of fertilizer. If you're trying to correct just nitrogen, you're trying to correct just phosphorus or potassium. And let's touch on that for a second. So let's look at this guy right here. I know right off the bat I don't have the phosphorus in this soil that I like. So what am I going to do to fix that problem? I'm not going to use a 10-10-10. I'm not going to use a lawn fertilizer that's 2205. I'm going to use something that has just phosphorus. And if you remember in the video we talked about in the past, there are multiple sources, but I'm going to try and use super triple phosphate. That's what I like to use because the salt index is so low. The potassium comes back low, which is going to a little bit. Then I'm going to use probably sulfate of potash, again the salt index being low. And I'm going to calculate each one of these individually for each one of those particular fertilizers. It gives me more granular control of the application and how I need to space it, to where if I tried to force it with a 10-10-10 or whatever, I'm really going to throw everything out of whack here because I'm not dialing in just to those two nutrients. Calcium, if this was low, I'm going to address that with either gypsum or Solucal or domolytic lime. I'm going to use domolytic if this number was real low to get the magnesium up. But in this case, I don't need to touch magnesium. I may need to change my calcium if my calcium to magnesium ratio is off, which these two right here are supposed to be 6 of these to 1 of these. Or I may even use gypsum if what I'm trying to do is change my calcium, but I'm not trying to net a pH change. The micronutrients, we would do that with a micronutrient package, be it a liquid application or, a granular application. But typically these come after the fact. A lot of people try and focus on all of this at one time. I would tell you and encourage you that if these right here are off, this right here is the least of your concern right now, unless they are so low they are non-existent. These guys here need to be addressed first so that your base saturation and all of your levels in this matches what you saw in the video of balanced soil. See, right now, technically, really, calcium is a little higher. Remember we said calcium was supposed to be 68%. But also, magnesium is a little high. So what we may have to do is push our calcium up a little bit more to get our ratio balanced here. So what I'm going to do, I've showed you how to interpret the soil test. In one of the videos, I'm going to show you the calculations of how to correct your soil based on the soil test. While we're talking about soil testing, let's talk about something else. Let's assume that you have an absolute perfect square yard and your house is dead center of said perfect square. Okay? And let's assume that this yard is 26,000 square feet. That's kind of an average yard. We have a front, we have a side, we have another side. For right now, we'll just say left and right. And we have a back side. Now, in ideal testing, to get everything right, we're going to actually break this yard into 4 quadrants. Okay? We're going to break it into 4 quadrants. Each one of these will be its own soil test. Within that, we're going to take soil samples in a random zigzag pattern in each one of these. People ask, how many do I take? Well, the more you take, the more accurate the test will be, because it is based on what's called a plow furrow slice. What that means is, let's assume you take a 6-inch sample. A plow furrow slice per acre at 6 inches is 2 million pounds of soil. A 3-inch sample is 1 million pounds of soil. So now you can all of a sudden see that the number of samples that you take is going to greatly affect your averages. If I take 8 as opposed to, say, 16 or 32, I have far less to average. So what I encourage people is, the more you can take, and try and do it the same for each quadrant. Make sure it's a consistent depth. 6 inches is a good one, 4 is a minimum. And then when you do that soil test, make sure that however you did it depth-wise and number of samples this year and how you broke your quadrants up, you do the exact same thing next year. Let's say you have a bad spot right here that nothing grows in. You would take all your samples in here, that would be one test, and then you would take samples in here, and that would be another test. So in that case, we would have 5 tests here. So I hope that explains to you how to properly do a soil test, how to interpret a soil test. And when we get into the calculations part of it, you're going to see how we're going to tie all of this together. So, again, I hope this series is being helpful to you. And stay tuned for the next video. I'm going to try and get some of the other ones done this weekend and then load them up next week. Thanks again for watching, and don't forget to hit the like and subscribe button. Till next time, take care, my friends.